Welcome back to this video, and this is the last video of Traversal series. So previously we have observed the in-order traversal and then pre-order traversal, and today we are on post-order traversal. So this is the in-order traversal. In-order traversal first to process the left side, then we process the root, and then we process the right side. So this traversal that is called the in-order traversal. This is called the in-order traversal. That means first we'll be processing the left side, then root, and the right. So in this in-order traversal, if we just bring the root in the pre-position, that means in the first position, then it becomes a pre-order. So the pre-order becomes like this: root, then we process the left, and then we process the right. So this is pre-order traversal, and we call this traversal the pre-order traversal. And what if we just push the root in the back in the post position? This is the post position, that is become the post order traversal. So in today's series we'll be understanding the post order traversal. That means this will be root I'm sorry, not root goes in the back, so it will be left, then right, then root, and then it becomes the post order traversal. So one important things to notice is that I made you understand pre-order, and then I made you, and before that I made you understand the in-order. So if you watch all the series, it will become very easy for you to understand. So in pre-order, what we did, we printed in this order, we printed in that order from root left to right, and now see, and here we print actually in this order. So we are printing actually in typical opposite manner. So we will just do nothing in here. One things we will be doing, that we will simply print the, we'll simply follow all the code lines, all the concept. We'll just follow the concepts from this pre-order. We'll be following the concept from this pre-order, and we'll be directly implementing in the post order, but in the opposite manner. Previously we have used here only one stack, but now here we'll be using two stack. We'll be first processing all the elements here, and then whenever we'll be popping the elements, we'll back pushing here to convert into a post order. So our concept will be very same. Let's again understand the recap concept. So first we'll be doing like this. We'll be starting from this root node, like just like pre-order. So what we used to do, that while we are using pre-order traversal, we actually traverse the elements from right to left. In pre-order traversal, we traverse all the elements from right to left. That what we have done in pre-order traversal. That means we traverse from right to left in pre-order traversal, right and left. This was pre-order traversal. But as I told, that pre-order is the opposite of the, post order is the opposite of pre-order. So here we'll be traversing, instead of right to left, here we traverse from left to right. Here we'll be traversing from left to right in post traversal using iterative process. So this is a post border traversal. So here we'll be traversing from left to right. I'm telling again and again because it is important to remember that in post order we'll be traversing the elements from left towards the right, from left towards the right. So that's how we'll be traversing. And now one more thing to remember in post order traversal, that here we'll be utilizing two stacks. So let's understand by utilizing stack. So let's call it stack 1. Let's use a different color for all those elements. Let's use this one. So this is for stack 1. This is our stack 1. So that is, we are calling stack 1. So first we'll be entering all the elements in here, and then we'll be utilizing another stack 2. So that is our stack 2. Stack 2. So this is our stack 2. So how we'll be processing? First we'll be processing the root node. So at the first step we will be inserting the root node into our stack. So we'll be starting from this root node portion. So once we process from the root node portion, we'll be starting, we process first here. So first we'll be updating, we call it root node. We will be also we'll be also taking help of another pointer calling current node. So this is current node. So we'll be inserting this first element into this stack 1. We'll be inserting this 1 into stack 1. So okay, now once we push any element, once we push that element into stack, now we have to pop that element. Now we'll be popping that element. And once we pop the element, we'll just not pop the element. We will simply pop the element into another stack. So if we pop the element, we will directly pop the element from here and we will insert in this stack 2. So here comes the 1. So it came here. Now we'll be processing from left to right. So that means our current node will come to here, this position, current node. So now we'll be inserting. Now we'll be inserting the 2 here. Okay. So now we'll be inserting the 2 back into the stack. So we inserted 2. Then we'll be from left to right. So now we'll be inserting the 3 also. Now we'll be pushing that into stack 3. So we pushed the 3 also back. Once we have pushed the 2 and 3, now we will checking again, we will be checking once we processed one level. Now we'll be checking our stack that if this is having element, now this is not having one. So we check that if this 3 is having any child or not. In that section there is no any child, it encounters null. So we'll simply pop the 3, and we pop the 3 not just here, directly into this stack. So we insert 3. Once we insert 3, now we check the 2. 3 is not present here. Now we check the 2, and now we just pop the 2. Once we pop the 2 and we insert into this stack, now we have to traverse its next children of 2, because we are processing the 2 right now. So we'll be traversing its children, left children and right children. We have to traverse from left to right in here. So we insert 4 and then we insert 5, and back we just insert those 4 5 in here. So it becomes like 4. We pop the elements and 5 comes here, and then we pop the elements and 4 comes here. So that becomes our entire route. So when we just utilize it in the code, so we just pop all the elements one by one, and the entire water becomes like this. We just pop elements from one by one, and this becomes our final stack. It becomes the final stack from where we push all the elements back. So now our code will start encountering printing from here. So it will be printing all the elements like this. First it will be printing 4. So it will be popping the element 4. Then it will be printing element 5. Then it will be printing element 2. Then it will be printing 3, and then it will be printing 1. And once it encounters that the stack is empty, then it stop and our program will stop working. So this is how our program works like this, and for that we are utilizing two stacks. So let's see how we can write this code. So start from the beginning. First we will be taking help of stack in iteration process. So we'll be importing the stack. So just write import java.util.stack, java.util.stack. So first we imported java.util.stack, and now we will be providing a name to the function, because we have to make a function. So let's call it void PostOrder Traversal. So we'll be calling void PostOrder Traversal. So okay, we created the function. And now we will be checking the base case. We stopped the program when we encountered null here. Here we encountered null, and then we stop the program. So once we encounter null, we stop. So if root equals to null, that means if we encounter, then we simply return the program. Now we have encountered the null. Now we will be handling the second cases. We need to create two stacks. So first create those two stacks. So for that we'll be creating stack, and we'll be storing binary tree node stack 1 equals to new stack. Okay, now we'll be importing another stack, binary tree node. We will be also storing binary tree node inside it, and we call it stack 2, that is equals to new stack. So now we have created, by now we have created two stacks. And now after we have created a stack, what we have first done, first we have inserted one. And what is this one? This one is the root. This one is called the root. So we actually push the root into the stack one, into the stack one. So stack one dot push, stack one dot push of root. So now we have pushed the stack one, we have pushed the root into the stack one. Now we'll be checking if the stack one is empty, and if not empty, then we'll be running our program. So while stack one dot is empty, that means if stack one is not empty, then only our program will work. And now we will simply we pop the element, so we'll be popping the element, and after popping the element into a new node, or we can call it a current node, we will be back insert into the stack 2. So binary tree node, let's call it binary tree node, binary tree node, current node, that is equals to stack 1 dot pop, because we popped from the stack 1. This is the case when we had the root, the first element in here, and the element first that was 1. We popped back from here, so now it will pop back. So after we have popped back we have to insert the element into the queue. So we will be simply inserting that element. Next we insert it into the stack 2. So we'll be applying this stack 2. So stack 2 dot push, stack 2 dot push of current node. Okay, so now we have pushed the current node into the stack 2. After that we'll be checking, because we have checked here from left to right. This was the theory that we have to check from left side to right side. So we'll be checking if the left side is having any children. That means if the child is 1, 2, 3. So we'll be checking that if its left is having any children or not. So this is having children, so it will traverse like this. So we'll be writing the code lines for this, that one. If current node dot left, if current node dot left not equals to null, if the current node is not equals to null, if the current node is not equals to null, that means it's having element, and we'll be pushing that element into stack 1. So stack 1 dot push, stack 1 dot push current node dot left, current node dot left. So now we are pushing the 2. In that case the left is 2, so we are pushing this element into the stack. Next we'll be checking for the right condition for 3. If current node, if current node dot right, if current node dot right, this is not equals to null, that means it is not equals to null, then we'll be simply again pushing stack 1 dot push current node dot right. So we'll be pushing the current node dot right back into this stack. So this is how we can insert all the elements. And once we have started one the element, our this line, that stack 1 dot push, this line, this important line, stack 2 dot push. So it will check once we keep entering the elements like this, our stack 1, the stack 1 will entirely get filled with the elements. Stack 1 will get filled, and at the end it will keep checking elements, and then this line will pop all the elements from here, all the elements, it will keep popping all the elements from here, and at the end it will insert into the stack 2, stack 2 dot push. So we will be popping from the stack 2. So again we'll be using another line, that while stack 2 is not empty, that is not of stack 2 dot is empty. Now we'll be running system dot out dot println stack 2 dot pop. So simply we'll be popping the element stack 2 dot pop. So this method will pop the elements, and we will be printing not the entire node. Instead every node has a structure like this, and the data part 1, 2, 3 integers are stored in the data part, not in the left and right. So we'll be printing the stack2.pop.data. So it will be printing all the data parts for us, and it ends the code. So if we just write the code and if you try to observe, so it will simply be printing the line. So if you want, we can write the program. So this is the binary tree node post order traversal. So I have already created the post order traversal. Let's remove it and again try to write from the beginning. So okay, let's write. So now we'll be creating a file. These are the pre-order traversal that I have previously made you understand. So void post order traversal, post order traversal. And now we'll be simply base case. We'll be checking if the root is equals to null. And if the root is equals to null, simply return. We'll be returning. Now we'll be creating stack binary tree node. We'll be storing this one. Stack 1. So we have created, by now we have created two stack. So after creating the two stack, now we'll be pushing the root initial work. So stack 1 dot push. We'll be pushing the root into it. So after pushing this, we'll be check if stack 1 is not empty. That is not of stack 1 dot is empty. And if stack 1 is not empty, then only we'll be proceeding further. So now tree node, binary tree node, current node, that is equals to stack1 dot pop. So we'll be simply popping the first element, whatever the element was, and then we'll be pushing that into the stack 2. So stack 2 dot push the current node. So we have pushed the current node back into the stack 2. Now we'll be proceeding from the right. We'll be checking if current node dot left not equals to null. If this is not equals to null, it's having a children. So simply stack 1 dot push current node dot left. Okay, if current node dot right not equals to null, so simply stack 1 dot push current node dot right. So okay, well, by now we have pushed all the elements. So after this condition is executed, sorry, this is not if, that is while condition, that while not empty, so that it runs for while. So after this condition is checked, entirely all the nodes are processed. Now all the nodes are inserted into the stack to cause of it. Now we'll be popping and printing all the elements from here. So while not empty stack 2 dot is empty. Now we'll be simply printing all the elements, system dot out dot print ln, and we'll be stack 2 dot pop. We'll be popping in the elements, and the data part will be printing here. So it will be printing all the data part followed by space. So this is all the element we printed out the data part, and let's see if the code works or not. So we'll be compiling the Java compile file, and it just compiled. Now we'll be running the Java file, and as we can see, this is 45231. We got the result to be 45231. So let's check what we actually found for the first time. We got the result 45231. So by now we understood the post order traversal. So we'll be meeting in the next session.